Hello friends, welcome to TechCube Gate classes. My name is Vivek Singh Rathore and I am Assistant Professor in Government Engineering College Bilaspur, Chhattisgarh in Electronics and Telecommunication Department. I have done my Masters from NIT Delhi in Electronics and Communication, and from this video lecture series I will be taking Signals and Systems subject. It is mostly from the point of view of preparing GATE exam and other competitive exam which are taken by various other PSUs in Electronics and Communication Department. So let's get started with our first lecture, that is, and in this lecture I will be dealing with the syllabus of the subject. Actually, what GATE prefers, that is most important for us. So let's get started with the GATE syllabus of Signals and System. So if you can see the screen, you can see the syllabus. That is, it has been divided into two parts: continuous time signals and discrete time signals, and there are many topics which are mentioned in the syllabus. So if we can study line by line, that will be much easier for us to understand the concept, and then we can solve many questions. So seeing that this syllabus, I have prepared my modules in different pattern. So today I will be in this video lecture I will be telling you how we are going to start and what will be the content in this all video lecture series. So see, first if we will be seeing, that is classification of signals. This will be the first module which will be going to start, that is classification of signals. Okay, so in this chapter or in this module we will be seeing, see how a signal can be represented. Actually here first we will see representation of signals. Okay, so in this we will be going to see actually three different method, like graphical, okay, mathematical, and obviously functional. So this will be the first topic which we'll going to see. Then we'll be going to see many signals that are elementary in nature, that is elementary signals. We'll say it as elementary signals. Okay, and here we'll see some of the basic signal, that is unit step, unit ramp, okay, and then impulse signal, then sinusoidal signal, and then exponential signals and all. Okay, then we'll be going for basic operations. See, if we have seen the signals, how to represent signals, we have seen the basic signals, then will be seeing what basic operations can be performed on a signal. So here we will be seeing basic operations which are performed on signal. So basic operations means here will be going to see time shifting, time scaling, okay, and time reversal, and if here addition and multiplication of signals. This all topic will be going to see in this area. Then after that what we'll be going to see is classification of signals. Signals are of various types, so in this we'll be going to see classification of signals. In this we will be going to see many type of signals, like periodic and aperiodic signal, energy and power signals, okay, causal and non-causal signal, energy and even and odd signal. These all topics we will be going to see, and then at the last for this module we will be going to see classification of systems. Okay, so classification of systems, if we will be seeing, so here there are many systems like causal and non-causal signal, linear and non-linear signals, systems, time variant and time invariant system, stable and unstable system, invertible and non-invertible systems, Okay, so these type of systems we will be going to see. So let's not discuss whole syllabus in the first go. We'll be seeing, I will be dealing with first module on the first go. So these are the topics which will be covered in the first module. Later on, when I will go to second module, I'll be telling you what will be covering in the second module. So let's get started with our first topic, that is called representation of signals. Okay, then let's start with our first topic, that is called representation of signals. So before starting our first topic, first we need to understand actually what is signals. So if you see signals, what is the meaning of signals? Actually, signal is a function. Okay, so if you can say signal is a function that conveys information about a phenomena. Okay, so signal is a function that conveys information about a phenomena. Okay, so if you see in electronics and telecommunication, it signal is it refers to a time varying voltage, current, or electromagnetic wave that carries some or the other information. So like this. Okay, and if you see in human engineering, signals are typically provided with some kind of sensors, and often the original form of any input or any signal is converted to another form of energy, and that can be done by using any transducers. Okay, so that is the other thing. If you see systems are some of the mathematical representation between input and output signal, and that is called as system. So we need to understand actually first what is system. We need to understand the significance of signals, and then we can move forward. So now you have understood that anything associated with some information, that is called signal. So when we see representation of any signal mathematically or graphically, first we will see a gate pulse. Okay, this signal is called as gate pulse. This is represented as like this, and from this point to this point, let's suppose this point is minus t by 2 and this point is t by 2. Okay, and let the magnitude be 1. This is also called as rectangular pulse. Okay, so this is called as rectangular pulse. Now how we can represent it mathematically? So this signal is represented as ft, and ft is actually the value of ft is 1. If you see from it, the value of 1 is from minus t by 2 to uh, I think t and then t by 2. Okay, so this is the value, and from this range to this range it varies, this lies. Okay, and this value is ft is 0 for the value, otherwise whichever the value may be. So this gate pulse can be represented by this mathematical expression. Okay, now if second signal, what we'll take here is triangular pulse. Okay, so now we'll be taking triangular pulse. Triangular pulse, if you see this and this, so you can see from here to here, this is called as triangular pulse, and here we will take a range from minus t to plus t, and let the magnitude be 1. So how we can represent this triangular pulse? So see, you know the line equation. Line equation, if you know, mt plus c is the equation for line, where m is the slope. So what is the slope here? So let's for slope you can do y2 minus y1 by x2 minus x1. So here will be 1 minus 0 and 0 minus of minus t. So you will get the slope as 1 by t. M is 1 by t. And for c you can do what will be the value here? Let's see, at t is equal to 0, value will be 1, and m will be 1 by t, and for t we are taking at t is equal to 0, and this plus c. So c value is equal to 1. So the final equation, if you see, of this will be ft is equal to mt plus c, mt plus c, m is 1 by t, so I'll write it with this 1 by t plus c is 1. So this will be the equation for this line. The same thing here, if you see, you will get m is equal to minus 1 by t. So here also the same, c will be 1 only, so the equation for this will be minus 1 by t plus 1. So this equation or this triangular pulse can be represented as ft is equal to 1 by t plus 1 for t is less than minus t and less than 0, okay, equal to 0. And here will be minus 1 by t, I think minus 1 by t plus 1 for t, I think greater than 0 and less than t, okay, and this will be 0 for other point. So see, two pulse I have shown you. One is gate pulse and one is triangular pulse. Mathematical representation, graphical representation is very easy. Now we'll move on for the third signal. Third signal is exponential signals, okay. So we'll talk about some exponential signals. Exponential signals, if you see, there are two type of exponential signal. One type of signal will be like this also, one type of signal will be like this also, okay. So these all are exponential signal, but one is rising and one is decaying, okay. So exponentially decreasing signal, this is called as exponentially decreasing signal, and this is exponentially increasing signal, okay. This can be represented as e to the power at, okay, and this can be represented as e to the power minus at. This mathematical expression you can write it down like this. So in this topic we are going to see about the representation of signals, and we are seeing almost how we can represent these signals in mathematically. Now fourth we'll be seeing sinusoidal signals. Sinusoidal signals are some sine cos signals. Let's suppose here we see some sine signals are there, okay, let's see, and there are some cosine signals are also there, okay. If you see in sinusoidal signal, actually sinusoidal signals can be represented as sine t and cos t, that you already know. But here if you see, when these signals are crossing the 0 point, okay, these are called I think these are called as 0 point. So wherever they are crossing 0, that points are called as 0 crossovers, okay. So where are 0 crossover, that is ZCO. So here if you see sine signals, they are always crossing 0, like here this value is 0, pi, and this is 2 pi, 3 pi. So for sine signal, 0 crossover is n pi, okay. And whenever we see cosine signal, these are cosine signal. If you see here, 0 crossovers are there, so these are pi by 2, I think 3 pi by 2 and 5 pi by 2, these are there. So for cosine signal, 0 crossover are 2n plus 1 into pi by 2. So these values you need to remember, or you need to understand actually, then you can write it down. And then we'll go for our next signal. Next signal is, I think, unit step signal. So fifth is our unit step signals. Unit step signals are those signals which are having value 1 after t is equal to 0. Means if you are seeing unit step, mathematically it is represented as ut is equal to 1 for t is greater or equal to 0, and I think t is greater than 0, because for equal to 0 some average values are always taken. So ut is equal to 1 for t is greater than 0, and 0 for t is less than 0. This is the mathematical expression for unit step signal. and wherever you need to start a signal from t is equal to 0, you can just multiply with ut, that signal. So you'll get the signal which you want to get started after t is equal to 0. Now if you see unit step signal, you can you have understood. Now I think that was fifth part. So sixth part will see unit impulse signal. Unit impulse signal. So unit impulse signal, if you see, graphically we represent as this, like this, at t is equal to 0. Okay, and mathematically it is represented as delta t is equal to 0 for t is not equal to 0. Okay, when t is not equal to 0, this value is 0, but this is not equal to 0 when t is equal to 0. This condition you need to understand. Okay, and our delta t is not equal to 0. Actually this value is unmeasurable energy. Okay, this value is very unmeasurable, enormous amount. Like you can see example, like see, if you sparking of lighter, or when clouds lighten, so these are in very less amount of time, enormous amount of energy is scattered. So that is unit impulse, means very, for a very few seconds or very short duration, sudden spark is there, that is called unit impulse in practical time. So this is delta t, and this is equal to 0 for t is not equal to 0, and this is not equal to 0 for t is equal to 0. This is delta t. And if we want to calculate this enormous energy or enormous power, so you need to do integration minus infinite to infinite delta t into dt. When you do integration of this and equate to 0, then you can get the enormous amount of energy there. So actually this was proposed by Dirac. So this is called as Dirac delta function. Okay, so these are all some elementary signals. One signal is left, that is called, I think this was sixth part. So seventh part I will tell you. Seventh is unit ramp signal. Unit ramp signal. Unit ramp signal is see, ramp, you have seen ramp is nothing but like, see this and suddenly this is called as ramp. So when it is starting with t is equal to 0, so we can say that it is represented as rt. Okay, unit impulse was represented del t, and unit step was ut. So ramp signal is represented by r. Okay, and it is starting at t is equal to 0, that's why I am taking here as t. Later on I will be telling you how we can do shifting, and then you can write rt minus 1 or something, but here it is starting with rt is equal to 0, so we will write rt. This value is ramp signal, and here it is value is basically this slope is I think here we can say t, because m is 1 and slope is 1, m is equal to 1, so mt plus c is equal to 0. So you can say rt is equal to t for t is greater than 0. Okay, and is equal to, I think, 0 for t is less than 0. So this is basically mathematical representation of unit ramp signal. So I think in first lecture we have studied about basic type of signals and how we can do mathematical representation for this. In second topic, in next lecture, we'll be dealing with how to do basic operations like time, how to do time shifting, time scaling, time reversal, addition and multiplication for these type of signals. So we'll meet in the next lecture. Till then, tata, bye bye, see you, have a good day.